All right, for the first video of Notes 41, I'm going to do some problems on solving quadratic equations. So quadratic equations in this general form are ax squared plus bx plus c is equal to 0. And if you can get it in this form, you can use this lovely formula right here. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And that will tell you what x is equal to. So the a, b, and c in this equation come from the a, b, and c in this equation. Now, what you're going to notice is part A and part B here for question number 1, they're the exact same question. And what I'm going to do is I'm going to do part A with solving quadratic equations, all right, as in solve with quadratic formula. So there's a whole bunch of ways to do this. So we're going to start with, and I'm right above my little letters here, my equation, I'm going to make a little note here. So A is equal to 1, because that x squared is by itself, okay? B is equal to the negative 2, right? It's bx, so whatever this x term is, that's its coefficient. And then c is the constant, which is this little number here that has no x attached to it, so that's going to be the negative 8. And each one of these numbers is going to fill in to the quadratic formula. So x is equal to the opposite of b, plus or minus the square root b squared minus 4ac all over 2a. And what's going to happen here is each one of those variables that I just, painstakingly wrote down is going to get replaced with what it is equal to. So anywhere I should have a b, and I have 2 of them, opposite of b and b squared, those get replaced with negative 2's. Anywhere I have an a, so 4ac and then 2a, those get replaced with 1's. And then the 4ac, the c gets replaced with negative 8. All right, so this is basically, and I say basically, but a quadratic formula is basically a substitution problem. All right, and now that we've substituted everything, we want to simplify everything. So I have negative 2, or the opposite of negative 2, so that's going to be positive 2, plus or minus square root. So let's see, negative 2 squared is going to be 4. Then I've got negative 4 times 1, so this is negative 4. And the negative 4 times negative 8 would be positive 32 all over. And by the way, please make sure when you're doing this, you keep that fraction bar over or under the entire numerator. So both parts. And then 2 times 1, of course, that's just 2. So x is equal to 2 plus or minus the square root of 4 plus 32 makes 36 all over 2. Let's see what we got here. So we've got 2 plus or minus. Well, the square root of 36 is just 6 all over 2. Now, here's the fun part. This is completely now simplified. There's no more roots in there. So I'm going to go ahead and split this and actually simplify the fraction that I create by this. And what I mean by split it is I'm going to make one fraction 2 plus 6 over 2. And then I have another fraction 2 minus 6 over 2. So first fraction, 2 plus 6 is 8. 8 over 2 is 4. And then 2 minus 6 would be negative 4. Negative 4 over 2 is negative 2. So I'm going to tell you that x is equal to 4 and x is equal to negative 2. So those are my solutions for problem number 1 using the quadratic formula. So I identified A, B, and C, substituted into the quadratic formula, simplified some more, and then simplified to the end. All right, and I get 2 lovely answers here. Now, part B is the exact same equation, right? Exact same equation. But here's the difference. In part B, the first thing I'm going to actually try and do with any of these problems, unless the directions explicitly state solve with quadratic formula, if it just says solve, my first thought is, can I factor this thing? And the answer is yes, I can. All right, I'm looking for things that multiply to negative 8 and add up to negative 2. So x minus 4, x plus 2. And then once I've got these factors, I can set, hold on, helps if I actually write the factors correctly. I can actually set them equal to 0 to solve. So that's going to get me x is equal to 4 and x is equal to negative 2, which should be absolutely a surprise to no one because it's the same question. Okay, So here's the thing. Is it going to matter in a problem if you factor it and solve it, or use the quadratic formula and solve it? The answer is no. If you can factor a problem, factor the problem. If you can't factor, that's when I tend to lean into doing quadratic formula. All right, so that's where the only difference would come in for me. I will be 100% honest. I find this faster than dealing with quadratic formula. But if I cannot factor, I don't have the option of doing this. All right, so question number 2 says to solve. And initially, I'm going to try and see if I can factor. So can I find two numbers that multiply to -5 and add up to -2? No, I can't. So this is, to me, a perfect idea of where I have to use quadratic formula. So A is equal to 1, B is equal to -2, and C is equal to -8, -5. There we go. Okay, got all the pieces in the right place. So x is equal to the opposite of b plus or minus square root of b squared minus 4ac all over 2a. You do need to know the quadratic formula. I am not going to sing it to you because absolutely no one needs to hear me sing. But if you do go on to other YouTube videos, I'm sure there are some fabulous videos of many, many people singing the quadratic formula to various tunes. Feel free to find the one that makes you happy. So A and A, and then -5 for my C value. Okay. So let's simplify what we got here. So x is equal to the opposite of -2, so that's going to be 2, plus or minus the square root. -2 squared is 4. Now, for this part, I do take it apart in pieces, but I have to multiply all three numbers. So -4 times 1 is -4. And then this answer of -4 times -5 would be positive 20. All over 2 times 1 is 2. All right, so x is equal to 2 plus or minus the square root of 24 over 2. Now, I can't take the square root of 24 off the top of my head. It is not a perfect square. But what I can do is break up the square root of 24 using my prime factors, my factor trees. So let's see, 2 and 12, 2 and 6, 2 and 3. So 2, 2, 2, and 3. So we have a pair of 2s, and then the 2 and the 3. So there's my pair of 2s. The 2 and the 3 that didn't pair up just multiply back together under the root. So that's going to become 2 root 6. So x is equal to 2 plus or minus 2 root 6 all over 2. And I recognize that I have a 2 here, a 2 here, and a 2 here, and they are all, of course, divisible by 2. So x is equal to 1 plus or minus root 6. 2 divided by 2 is 1. 2 divided by 2 is 1. So there's 1 root 6 there. I'm lazy enough to not write it. And the denominator is 2 divided by 2 is 1. You do not need to write a denominator of 1 if it is unnecessary. And it is unnecessary right there. So problem number 2 there solves into 1 plus root 6 and 1 minus root 6. And we're going to let that be what it is there. And then for part, I think this is a 2b. There is 2b. Let's see what we got here. What I'm trying to do in my head is see if I can quickly factor it, because if I can, trust me, I want to. And unfortunately, no, we're not going to be able to factor this mess. All right, so let's go ahead and do A is equal to 3, B is equal to 4, and let's see, C is equal to -8. So x is equal to the opposite of b, plus or minus the square root b squared minus 4ac all over 2a. So let's see, b here and here, a here and here, and of course c at the end there. Okay, so x is equal to the opposite of 4, so -4, plus or minus square root. So 4 squared is 16. Okay, 4 times 3 is 12, -12. So negative 4 times 3 is negative 12. Negative 12 times negative 8 is going to be a positive something. So 12 times 8, 96. All right, so 96 all over 2 times 3 is 6. All right, so let's see what can break out a 96. I don't know too much, but I know I should be able to use a 2. It's an even number. So that's going to be 48, I think. And then 48 would be 4 times 12. So 2 and 2, 2 and 6, 2 and 3. Let me do one quick double check to make sure I didn't screw something up here before I get too far into this. Nope, it is. Okay, I did work that out right. All right. That's a lot of 2s. All right, so 2, 2, 2, 2, 2, and 3. I'm going to do a quick double count. 1, 2, 3, 4, 5 2s. 1, 2, 3, 4, 5 2s and a 3. Okay. So I've got a pair of 2s here. I've got a pair of 2s here. So, whoops, right with a pen, right with a pen. So 2 times 2, and then the 2 things that didn't multiply together, or 2 things that didn't pair up multiply together to just stay under the root. So let's see, x is equal to negative 4 plus or minus 4 root 6 all over 6. Now, in the last problem, I was able to completely divide out by 2 because everything was a 2. Unfortunately, negative 4, 4, and 6, they don't completely divide out, but all of them are divisible by 2. So negative 4 divided by 2 is negative 2, plus or minus 4 divided by 2 is 2 root 6, and 6 divided by 2 is 3. All right, that is a whole bunch of work there, but that is the final answer there for question number 2, part B. All right, this video has gone on long enough, but this is all the information about using quadratic formula to solve these quadratic equations. As always, let me know if you have any questions or concerns, and I will see you in the next one.